All right, remember what we're focusing upon here is interval estimation. And we're going to have some interval, plus or minus some amount, right? And we'll have some confidence that we could say that the point estimator for whatever characteristic we're measuring, whether it's the mean or the proportion, is like with some confidence, it's within this interval, right? The population parameters within this interval. Established by the point estimator plus or minus some amount. With some confidence, we'll say the population parameter for the characteristic we're measuring, whether it's the mean or the proportion, with some confidence is in that interval. This is interval estimation, ladies and gentlemen. Interval estimation. And so here, what we're going to see in this video is this and this. And so you can pause the video here, and you can pause the video here, and you can read through these. And now I'm going to talk you through them. And so again, what we're learning is vocabulary. We're learning how to speak a new language here. And we're learning new terms. And so that's what we're going to mostly be learning in this video. And so there's a margin of error, like, 95% confidence. And then there's some interval, some estimate. And so here, margin of error plus or minus a certain amount. And then there's also some confidence. But we could also, to understand this, we could copy this. And we could go to ChatGPT. And well, first let's finish reading this from the previous video. But once we're finished reading this, we could ask it this question here. Please explain. Boop 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 for me. Please explain margin of error and the interval estimate for me. So in simple terms, interval estimation in statistics is a method used to estimate a range of values that is likely to contain the true value of a population parameter, like the mean or proportion, based on sample data. Instead of giving a single number, a point estimate, interval estimation provides a range or interval called a confidence interval, which tells us how confident we are that the population parameter lies within the range. For example, instead of saying the average height of adults is exactly 170 centimeters, interval estimation would say we are 95% confident that the average height of adults is between 168 and 172 centimeters. So 170 plus or minus 2 centimeters. Key terms: confidence interval, the range of values. Confidence interval is the range of values from here to here. Confidence level is the percentage, like 95% or 99%, that reflects how certain we are that the true population value lies within the interval. So interval estimation gives a better understanding of uncertainty in estimates, especially when dealing with population data. Man, it's amazing. This is truly amazing. So I'm going to go back to our definitions here. I'm going to modify these. And I'm just going to make that really small so we have less space between our stuff here. And get a little bit more room and make that super small. And it doesn't really move things down very much. But that's okay. And you work with what you got. And now I'm going to add those two in there. And I'm just going to bring this down. And I'm going to bold this. Actually, these should be bullet points too. So I'm going to make these bullet points. And except like when I make them bullet points, they start to go off the screen. I don't know what to do about. I'm going to go back to this way. So we're going to do confidence interval, boom, and we're going to do confidence level. And confidence interval is the range of values. This would be our confidence interval, and confidence level is percentage, like 95% or 99%. So here's our confidence level that reflects how certain we are that the true population value lies within the interval. Awesome. So we got this first part done. Now we're going to ask it this next part. Please explain margin of error and the interval estimate for me. So margin of error and interval estimate are key concepts in statistics, particularly when estimating population parameters. Margin of error represents the amount of uncertainty around a point estimate, like a sample mean. It gives us an idea of how much the sample estimate might vary from the true population parameter. Margin of error is often influenced by the following factors. Sample size, right? Like if we only sample one person, right, we're not really getting great insight into what the population's really like. If we sample 2 people, we get a little bit better insight, but not that great. We start to get more insight when we get up to like 30 people, right? So the sample size, the larger sample sizes reduces the margin of error. Confidence level. Higher confidence levels, like 99%, increase the margin of error because we want to be more certain the interval contains the true population parameter. If I have like 99% confidence, I have 99% confidence that the mean height for humans is somewhere between 1 foot and 10 feet. Okay, I increased since I wanted a high level of confidence, I increased the margin of error because we want more certainty the interval contains the true population parameter. Variability in the data. More variability or standard deviation increases the margin of error. And then interval estimate, the interval estimate, confidence interval, right? And so here, up here, we learned confidence level, right, is 95% or 99%. Interval estimate, or confidence level, provides a range of values within which we expect the confidence interval, which is right here, the range of values. So the interval estimate, or confidence interval, provides a range of values within which we expect the population parameter to fall. It is calculated using the sample estimate, like the sample mean, plus and minus the margin of error. So here we have a confidence interval. It's also known as our interval estimate. It's the point estimate plus or minus the margin of error. So if we look back at our example here, this is our margin of error, right? This is our confidence level, and this is our confidence interval, or our interval estimate. And so margin of error, we'll put this down here as a definition, and to do this we need to drag this up a little bit, and we'll do that, and we'll just add this. We'll do this, Control Z to undo that. We'll copy this and Control, there we go, and we'll do margin of error, and that is the plus or minus 1.23 inches part. So that's like plus or minus a certain amount, right? That's the margin of error. This is the confidence interval, and this is our confidence level. Okay, so here we have a confidence interval, and it's plus the point estimate plus or minus a margin of error, and so there it is. So here's an example. If you're estimating the average height of a population based on a sample, and your sample mean is 170 centimeters with a margin of error of 2 centimeters, the interval estimate, or the confidence interval, and so we could do confidence interval or interval estimate, right? Also known as, and we'll do AKA, and then we can make these not bold, just to make it a little, I liked it better bold, there we go, is the range of values. And so this means you're confident, based on your confidence level, that the true average height of the population lies between this interval estimate, or this confidence interval, right? Confidence interval. And even me, I'm like, okay, how do I use these words, these terms? Am I using it right? So it takes a minute just to learn where to use them. In short, the margin of error determines how wide the interval estimate is, and together they help us understand the range within which the true population parameter likely falls, giving a more complete picture than just a single estimate. All right, so this is interval estimation. That's new terminology. And here we're going to jump into, now we know margin of error. That's that plus or minus, plus or minus 1.23 inches in this example. And our interval estimate is the point estimator plus or minus the part margin of error. Point estimate plus or minus the margin of error. You see it right here. So a point estimator cannot be expected to provide the exact value of the population parameter. An interval estimate can be computed by adding and subtracting a margin of error to the point estimate. Point estimate gives us plus or minus margin of error, and that's our interval estimate. That's our interval estimate, right? Interval estimation, confidence interval, interval estimate, okay? The purpose of the interval estimate is to provide information about how close the point estimate is to the value of the parameter. And then we have this, the general form of an interval estimate, or a confidence interval, of a population mean is x, which is the sample, right? The lowercase x, with the bar over it, it's the sample mean. And so we have the sample mean plus or minus the margin of error is our interval estimate, right, of a population mean. Okay, so that's where, like, you got to be focused on the different notation and what, this is for a sample, and we're going to use that sample to estimate the population mean, which the population mean is going to be mu, right? That would be mu. So that's how all that works. And so that's our next chunk of definitions. In the next video, we're going to start taking a look at, we're going to learn more about interval estimate of a population mean when we know the standard deviation of the population. The standard deviation population, standard deviation. When we know the standard deviation of the population, we're going to see how to build an interval estimate of a population mean using our sample data. See you in the next video.